Welcome to the second round of talks of this year's Big Tech Day. Time to mix ancient history and modern technology. I'm delighted to welcome back Professor Christian Große after a great talk he gave at last year's Big Tech Day. This time he is joined by Mohammed Elkarmoty. After studying mining engineering at Cairo University, Dr. Elkarmoty received his PhD in resources and earth engineering from the University of Bologna. He is currently an associate professor of geological engineering and mining, the director of the Rock Engineering Laboratory, and the co-chairholder of the UNESCO Chair on Science and Technology for Cultural Heritage at the Faculty of Engineering at the Cairo University, as well as the deputy coordinator of the ScanPyramids project. In 2022 and 2023, Elkarmoty was awarded the Cairo University Encouraging Award in Engineering Sciences and the Cairo University Trophy, recognizing his participation in the discovery that they will tell us all about in just a few minutes. Another central figure in that discovery is Professor Christian Große, who has a doctorate in civil engineering from the University of Stuttgart. After habilitation in materials testing, he became a professor for non-destructive testing at the Technical University of Munich. He has developed and applied innovative testing methods for buildings and facilities, including ultrasound, impact echo, radar, computer tomography, just to name a few. Professor Große has published roughly 500 technical articles, book chapters, and books, as well as 6 patent specifications to date. Applications of his work include the structural health monitoring, but also research of architectural monuments, such as the Pyramids of Giza. This talk will be streamed. If you're joining remotely, please just ask your questions in Zoom. For everyone else, we will have questions in the end here in the room. Please join me now in welcoming these 2 exceptional speakers as they reveal the secrets of a corridor inside one of the best-known monuments on Earth, but hidden for 4,500 years.
Thank you. Good morning, ladies and gentlemen. I'm very pleased to be here with you to share our experience in the ScanPyramids project and our latest discoveries. I would like to thank TNG for this kind invitation to be here with you. Our presentation today will reveal that, or prove that science and technology can reveal hidden secrets for 4,500 years ago. I will share this presentation with Professor Christian Große, our partner in this project, and we are both representing a ScanPyramids team. So, what is ScanPyramids? Why and how? ScanPyramids started in 2015 under supervision of the Supreme Council of Antiquities in Egypt, and is coordinated by Cairo University and a HIP Institute in France, and with partnership from Japan, France, Germany, and Canada. From Japan, we have KEK, NHK, University of Nagoya. From Germany, we have Technical University of Munich, Professor Große. From France, we have CEA and HIP Institute. And from Canada, we have Laval University. We are all working together in a multidisciplinary approach to achieve the objective. I think everyone knows Giza pyramids, but you know, we have more than 100 pyramids in Egypt, but the most attractive pyramids are the Giza pyramids, you know? Okay, the Giza pyramids were built 4,500 years ago, and it was built as a tomb for the king Khufu. What makes the Great Pyramid or Khufu Pyramid is a mystery, because so far we don't know exactly how the pyramid was built. There are a lot of theories, and we don't know fully what is the internal structure of the pyramid. And so far, no mummy of King Khufu or treasures of King Khufu was discovered so far. So we are trying to use science and technology to investigate the internal structure of the Great Pyramid. If we know what is inside the internal structure of the pyramid, we can understand more how the pyramid was built, and archaeologists can do interpretations for the archaeological aspects. This is the internal structure of Khufu Pyramid. You see, when you go This is the entrance. And above this entrance, this is the chevron. You can see this shape or this geometry just above the main entrance. Okay, this is the descending corridor. And then we have the ascending corridor that leads us to Grand Gallery, very large tunnel. Then, at the end of the Grand Gallery, we have a small corridor leading to the King's Chamber. And above the King's Chamber, there are some few very, very small rooms, 5 rooms. And above these rooms, there is a chevron-shaped structures. Okay? This is named the chevron shape. And here, when we go horizontally to this Queen's Corridor, we can find the Queen's Chamber. And here you can find also that the roof of the ceiling of the Queen's Chamber is chevron-shaped. Okay? I am pointing out this because this will give you more explanation in the next slides. Is it just the internal structure, or there is something that we don't know? This is the objective of our project, to know if there are some rooms, some more corridors. The only one who knows what is the internal structure is this guy, Hemunu, the architect of the Great Pyramid. So how was the Great Pyramid built? As I said, there is no clear evidence how the pyramid was built, but the main theory is that it was built as ramps, and blocks were moved through ramps until reaching to the end. But we don't have evidence so far, and it is the most logical theory of building the pyramids. I now leave the word to Professor Christian Große, who will explain and present to you the scientific techniques we have used in this project.
Thank you, Mohammed. He's coming back. He's coming back. Well, actually, when I was joining the ScanPyramids team, I was told by my colleagues, "What are you doing there? It's probably the best investigated building of the world. So if you want to have some new findings," and we already heard that only a small fraction of the pyramid is really well known, like, for example, 20%, yeah, then you have to form a really good team, as we've heard. And this is what I really liked in the previous talk from that girl from Bielefeld. She said, "Choose your companion wisely." And that is what we did, actually. We formed a really good team, but the next step would be choose your devices and methods wisely. So I'm now following with the more technical, boring part, and I try not to do it too much boring. Actually, if you are setting up a measuring device, a measuring companion, actually, in that field, it's not a good thing just to use one device. That is, if you go to your physician, to your doctor, and he's investigating you, then probably you get a bad message, and then you want to have a second opinion about that. And this is what we did here, but we compiled 6 opinions, actually using digital models, digital simulations, visual inspections, of course, that's the first step, as always, in non-destructive testing, infrared tomography, myography, ground-penetrating radar, ultrasound, and what we call electric resistivity tomography. That are state-of-the-art techniques, and all the, I would say, good experts of the world were compiled, bringing together their expertise with the state-of-the-art devices here to Egypt. We don't have too much time to go into all the technical details, so I will go on with the myography, because that was the major first step to go on. Myography, that are particles from space, and they are all around us. While we are sitting here, several thousands of myons are penetrating through your body. Yes, your body as well. And that is of no harm. they are just existing, and they are passing also huge structures. And that muon particles are, of course, also penetrating through objects like buildings, like the pyramids, and the denser the material is, the more muons will be absorbed. So this is a good concept, but how can you apply that? I always compare that to similar techniques like CT scanning or MRT scanning that most of you probably have always have previously done, experienced in the ambulance or in the clinical research. If you look at the sketches, at the images, you see there's a really good detail of their techniques at the human body. Well, I'm, as a professor, giving many talks, and I'm normally not allowed to present to you patient details of foreign persons. So what you see here, this is my brain. So you can see clearly, at least I hope it's not empty. And there's a really good detail. So what we are doing is, in clinical research, there's the detector and the emitter that is going around the person. And this is, most cases, not possible in material science, where we have to rotate the materials. And then we have always a fixed location of detector and emitter. But this, both, I would say, is really difficult with the pyramids as well. So we had to find a different concept. And the concept is just to have the muons detected at a certain angle, opening angle, and set the detectors wherever it is possible at the pyramids. The pyramids of Giza, as Mohammed, I think, already said, is one of the unicorns of the world. It is one of the ancient seven wonders, and it's still one unicorn of Egypt that have to be protected. I think it's our all-world cultural heritage, so it is very natural that we cannot disturb that, or we cannot scratch or even drill holes or whatever. So non-destructive testing techniques should be applied, and doing that with a muon technique, you have to put in the detectors at places that are accessible inside of the pyramid. And this is what you can see here, that are rooms and hallways inside of the pyramid where you can put in your detectors. So if you later on have questions in regard to the detecting techniques, there are actually 3 different ways to detect muons. Then I'm very happy to answer all your questions. For now, it's only important that you see that there are 3 different detecting techniques. As the physicist said, there are 3 different devices. Because that is important, you should base your analysis not only on one approach, and not only the 6 approaches that I've summarized, but also in each individual technique field, you should throw in all the knowledge that you have. So what we did is to obtain myography with silver photographic films, detectors using plastic scintillators and electronic gas detectors. Next technique we've applied was ground-penetrating radar. I'm not sure, but I guess whoever is driving around here in the city of Munich already saw that speed reinforcement boxes that we all like so much, right? And most of them are based on radar technique, and that's not a big difference to the radar technique that we've applied. The big difference is only that we are not penetrating the electromagnetic waves that are radiated by the radar antenna through air, but through the ground or through objects like buildings. And then we are obtaining the reflections. It's like you see here this nice guy in the animation, like a lawn cutter, you're driving, and then you can obtain information about the interior that are invisible from the surface with the naked eye. But there's one point that you should have in mind. Penetration depth is closely related, proportional to the frequency, and resolution is proportional to 1 to the frequency. So there's a trade-off between both. The deeper you want to go, the worse the penetration, the better is the penetration, but the worse is the resolution. And this is why we are ending up with so many different devices, because on the market there's no device that can cover all that penetration and resolution and also amplitude requirements we have at that unique investigation object as it is Pyramids of Giza. So you see here some of the radar devices we've applied, and that gives you an idea how complicated that project was and how much effort we had to spend into the measurements. Here are some examples of the measurements. You see here the team from the Egyptian side together with the German side, and we've included also colleagues from the Ukraine, from Russia, from Mexico that were part of our teams to do the measurements under really difficult circumstances because it has to be totally non-destructive. And the surfaces, of course, are also 4,500 years old, and deterioration processes doesn't make the life easier for doing the measurements. And please don't look too closely onto the scaffolding. I would say in Germany, working safety regulations are a bit different from what you can see here. But nothing happened, and we always applied the highest security standards as far as possible. Next technique, as far as possible. You don't have to travel to the South Pole to be in danger, but there was no harm here. Ultrasound was the other technique we've applied. That is also applied in medical applications. As you can see here, this is also a private picture. As I promised you, the most is private here, what you see. And that is done in, for example, prenatal diagnostics to look inside of the human body of a pregnant female, for example. And there's no physical difference to the application of ultrasound, what we do. Well, actually, one major difference is that we use, of course, the highest standards for material testing, non-destructive material testing, and that is requiring many signals. It's not only what you can see here with that little pair of ultrasound emitter and receiver, it's many of those, because we need a lot of data. The more data you use, the better is the signal-to-noise ratio. And that's really crucial because we want to look deep into the pyramid, as deep as at least 1 meter or 2 meters behind the next row of stones. And for that, we need good devices, and one of the state-of-the-art devices is shown here. This is what we call the synthetic aperture focusing technique, where you have rows of emitters consisting of 3 individual ones, and then the others are listening, then the second row is emitting, and then the others are listening, and so on. So you're ending up with many data, and all of them are calculated, put into a database, doing a lot of data processing to get the best out of that data processing techniques. And this is our device here from the Technical University of Munich. You can see here how it is operated. And we are very happy to be here with TNG, and they've been so nice to donate one of that devices that we've brought up here. You can see one of the devices that we are using now in the field for the next measuring campaigns. This is also one important outcome for us, that we are training the Egyptian young scientists. We still want to collaborate with them, but they should be able to perform such measurements on their own in Egypt. So this is really important, and we are very happy for the donation to TNG. Thank you for that. That is very helpful because, as you might probably not know, it's very difficult to do fundraising in that field because there are not so many funding agencies funding such research. Yeah, that was a short note on money. I'm not talking too much about electric resistivity tomography. That is an electric technique, and while the other techniques like ultrasound radar have been able to detect boundaries, for example, boundary between stones and air voids, you can look a little bit deeper also in larger voids, identify what, for example, is an anomaly, what kind of anomaly it is. With electric resistivity tomography, and that is a technique that is here on display using electrodes that you normally stick into the ground or into the object. What is, as I said, not possible with a pyramid, because then you have to drill a hole, and that is strictly forbidden. Even you cannot take a little stone or some sand from the pyramids with you. That is absolutely no-going. So there have been developed some special sheets that you attach at the surface without any deterioration, and all the time people from the conservation departments of the pyramids were standing behind us in controlling what we are doing. So you see here how that was carefully attached. So now I'm ending up with a short video and handing them over to Mohammed again, that is showing a little bit how the pyramids are standing there and how the measurements have been conducted. This is the area of interest. And how do we know? Obviously because of the Mayan tomography. This will show me. So this is climbing up in the pyramids, and this is the interior of the so-called King's Chamber. This is the King's Chamber. This is something what is for normal persons strictly forbidden to climb on top of the pyramids, but there have been special permits doing that. That's the scintillators for the myography. Pyramid is here mostly called the Pyramid of Giza. So that is the pyramid of one of the largest pyramids in the world. And now I'm handing over to Mohammed back, who is interpreting for you the data.
Thank you, Professor Große. So all the techniques mentioned by Professor Große, we have used in our main two discoveries. Now I will take you to the latest discovery, just announced in March 2023, but we have an older discovery. But the target of this presentation is to show you mainly how we discovered the 2023 discovery, which is the North Face Corridor. This is a video showing that in this chevron area, by using thermography, we found an anomaly here. In all of this area compared to all the pyramid, there is a thermal radiation anomaly. This was the start. So this attracted us to do more investigation. And this was in 2016. There are other chevrons, as I said, inside the pyramids, and they have an engineering objective to protect what is blue. This is the Queen's Chamber. Why there are so many chevrons there? They should protect something. So we decided to investigate this area by using mimeography, emulsion plates. Nagoya team from Japan put emulsion plates in the descending corridor just below the chevron area. Simulation for the mimeography, and this is the result of the simulation. Okay, and this is we have seen also the results of the measurements, and we have seen that there is a corridor there. There is a reflection or a footprint of the corridor there. This one. This time we did not know that this is a corridor or not. We just see an anomaly. We don't know the geometry, we don't know the dimension. That's just we see there is a cavity here. Okay, so we know that behind the chevron at this moment there is a cavity with unidentified geometry, and we wanted to investigate this area more to know what is the exact geometry and dimension of this cavity. So Nagoya team has installed several emulsion plates in the descending corridor. Instead of doing just one, this is the first one they have done. We put several ones, and also in the Ma'mun tunnel to intensify the measurements of the mimeography detection. And they have found that after making intersections of all the cones of visions for the muons, they concluded that the corridor is about 9-meter length, and this is the location of the corridor. with dimension of 2 meter by 2 meter. Then the French team from CEA used the second myography techniques, which is the telescope, as Professor Große explained, and they put 3 telescopes in the descending corridor in 3 areas, and they found the same. So with 2 different techniques, we have found that there is a corridor-shaped structure here, and more or less in the same location between the 2 different techniques. In 2023, the myography work was concluded in a scientific paper published in Nature Communications, and this is the main summary of this paper. This is the location of the North Face Corridor. So after the conclusion of the scientific work of Nagoya and CA teams in 2019, we collaborated with Technical University of Munich, Professor Christian Große, to use GPR and ultrasound and ERT as well to investigate the chevron area in order to validate the discovery with several non-destructive techniques. This is the area. We have done 3 measurement campaigns, and we have built scaffoldings to cover all the chevron area in order to be able to do our measurements. This is the GPR technique. The measurements on the chevron, and this is the ultrasound technique. Was published as well in NT and E International Journal. So what is the story of this collaboration to end up with the discovery? This is the GPR measurements. We have used, as Professor Große said, several frequencies, because each frequency can give us accuracy and penetration depth different than the other one. We have used 200, 400, and 600 megahertz frequency. And we have done a grid on the chevron area in order to move our devices on very precise lines. We have done a dense grid with large spacing and a small grid with smaller spacing. And we have measured this area mainly with GPR and ultrasound. And we have also done image fusion between the results of GPR and ultrasound. This is the GPR grid, the intense grid, and this is the larger grid, and this is the ultrasound survey lines, and these are the lines selected for image fusion. This is the results of the GPR measurements. If we see here, this profile C, you can see that there is a reflection here highlighted by yellow, because we have the anomaly or the corridor just in this part, and in this part there is nothing. In line A, you can see that we have a reflection here and reflection here on this line. You can notice that the reflection in this part is lower than this part, and this was strange for us. And later on, we have discovered that the block here is thicker than this block. That is why we have this reflection. So we have done also a simulation for the results. So the summary of the GPR measurements concluded that the anomaly is below the lower chevron just here in this area, and the ceiling of this anomaly is chevron-shaped, as you may interpret from here. We have done simulation as well, and the comparison between the GPR measurement and simulation is validated. Then we have done the ultrasonic measurements led by Professor Christian Große in several areas in the pyramid, but mainly on the chevron area. We have done several survey lines on a specific grid on the chevron. This is the result of the ultrasound measurements. You can see here profile A, for example. There is a reflection here and another reflection here on this line because we have the anomaly right here. We have done also numerical simulation and compared it with the measurements, which are validated together. Then we fused the results of the GPR profiles and ultrasound profiles together. This is the result of the GPR. You can see the anomaly here. And this is the result of the ultrasound. This is a fused image between GPR and ultrasound. You can see that the reflections and the anomalies from GPR and ultrasound exactly identical to each other. And this is the fused image without any boxes. This is the two reflections. The conclusion of this work, published in NDT and E International in March 2023 as well. And the conclusion is the width of this corridor is 2.1 meter. The side height is 1.4 meter, and the center height is 2.3 meter. So here, we need to see this corridor because it is really difficult at this point. And in order to convince Egyptologists and archaeologists, they prefer to see or touch the discoveries. So we have contacted the scientific committee assigned by the Ministry of Antiquities in Egypt and led by Dr. Zaya Hawass to present to him the results. And we have met him before announcement of the results at the Giza pyramids. And we showed to him this presentation, more or less. And at the end of the presentation, Professor Hilal, the coordinator of this project, told him, would you like to see the corridor by your eyes? And he says, how? Will you drill the pyramid? Absolutely no. And this was our main objective, is to see, after the discovery, is to show the corridor to the public. Then we have asked the scientific committee to go to the corridor, the North Face Corridor, the chevron area, in order to show them. But how we can show them? The only way, the first thinking, is to do a borehole from here. But this is completely not acceptable. And to insert an endoscope. But we were lucky to find just behind the chevron a small aperture between blocks. And we have used a very small diameter endoscope, 6 millimeter. And we have inserted this endoscope into a small tube, and we could see the corridor. This is Dr. Zaya Hawass with the team, and we are showing to him the corridor for the first time. He was very excited to see something hidden for 4,500 years. And we are all very excited at this moment. I will show you a video how could we inserted the endoscope to share with you the first moment of the discovery. We have inserted the endoscope from this very little hole. This is the camera of the endoscope. This is the tube. We are inserting the endoscope now, step by step. And this is the corridor. Thank you. This is a team when we have used the endoscope on this day. This is the endoscope itself with a large monitor to see the endoscope in a large picture. And these are two different images from the same endoscope. You can see that the endoscope is a chevron-shaped ceiling, which means that it is protecting something important here. We don't know exactly what is it so far. And you can see that this corridor at the end is blocked. There is a block here. Our objective right now with all the team and with Professor Große is to try to know what is behind this chevron, what is above, what is blue, using also non-destructive techniques. This is the image which reflects how much we were happy when we have seen the corridor for the first time. And we have been in the media in the top news of the media for 2-3 days after this discovery. So, as I mentioned, I focused on the latest discovery, but we have a major discovery in 2017, which is the Big Void, a much larger void than the North Face Corridor, and it is just above the Grand Gallery here. And the results of this discovery was published in Nature in 2017, if you would like to read about it. So, what are the key to success? You know, we are working together from 2015 with a lot of challenges. The key to success from our viewpoint are the science and the technology and innovation, the good international cooperation, and the dedicated teamwork, and good management and persistence to an objective. Thank you very much. Professor Große as well.
Yeah, thank you very much for this great talk, and I'm sure there will be questions.
Unique opportunity to ask questions. He's just coming from Cairo.
Thank you. I guess there are a couple of hypotheses as what the purpose of these voids actually were. You didn't comment on that so far.
That is true, because we are not archaeologists. Well, actually, as scientists, engineers, we are doing the discovery, but the interpretation, we have to cooperate with the archaeologists, because they have the knowledge on the overall construction. Well, when we started, I believe they showed us there is nothing in the pyramids, so we showed there is something, and of course the question is, what is the purpose? There are really different theories about, again, and I'm not an expert, and I think Mohammed also is not an expert, but yeah, we've heard about that. Well, one part, what was also, or one theory was also to distribute the loads from the top. But as you might see, it is different. The location is much different from the King's Chamber, what is inside of the pyramid. This is more on the outside. And there's not a lot of load. So as a civil engineer, you can calculate what would be the load distribution that is necessary. And this is 10 times stronger than this. And considering that the pyramid was built very nicely, very careful, and very accurate, I cannot believe they were doing such a miscalculation. So there must be a different meaning of that chamber. And probably, well, at the moment, our theory is that the answer is behind that blocks. So as Indiana Jones said, there is the next clue. And now it's becoming even more difficult because the deeper it is, the more difficult it is to investigate what is behind. And there's another discussion, as I may tell you, it's if we should open that void or not. This is another point which is totally out of our hands. So this would make life much easier if you can penetrate or if you can walk in and then do the next measurements. But at the moment it's under heavy discussion, and many people, including myself, say, no, please don't open that to public at the moment. Just let us first discover and investigate that unique opportunity of that room that is not accessed for the last 4,500 years. Where do you have a room where nobody went in for the last 4,500 years? The shape is very unique. You might have seen several details, in particular this dent-shaped objects at the ceiling. This is also very interesting to guess what was proposed, but it's not our duty. Is it?
Yeah, sure.
You agree, Mohammed?
I agree, for sure.
Thank you so much for this exciting talk about this very, very exciting topic. I have a question. Last year, when you held your talk here, you said, or you teased us about some more exciting
That's what
news
I
that
always
might
do.
come up. Yes, I wanted to ask whether you have something new that you can share that happened since 2023 in summer last year, something that you're working on.
Not worried, I did not say anything.
Yeah, don't worry.
If I may, I will answer in saying yes and no. We have more information, but no, we cannot talk yet about that. Due to a good scientific tradition, we have to publish that first. And that means that we have to present it to a journal and to the reviewers of the journal. So international experts in that field have to review what we found, and afterwards we can talk about it, but not before. I'm totally sorry. And I even may say, I hope you're not beating me, Mohammed, that's not only one discovery. There are several. And this is what we really like to take home from this talk. With that scientific engineering and physical techniques, there's opening up a new world of archaeology, because that techniques have rarely been applied to objects in archaeology. And that concept, combining different NDT techniques and experts from all over the world, data processing techniques and so on, this is really new to archaeology. And also putting in all the data processing techniques that are available. Most of you are experts in computer science, data processing. I can tell you this is really great, because we need artificial intelligence, machine learning techniques to deal with all the thousands, hundred thousands, and millions of data. This is the key. And I need to ask you for your patience. Very soon there will be more publications and new findings.
Thank you very much. We also have a question from our remote guests. I'm going to read it to you. The question is, did the Egyptians have a different weight and length measurement system than we have?
Sorry, I could not hear you.
If the Egyptians have a different length and weight
okay.
measurement system.
You know, this is a little bit archaeological question, and I don't want to say something that I am not sure about. So I would propose to ask archaeologists or Egyptologists. Yeah.
Thank you. Is smart dust, or in future more science fiction, nanobots considered a next investigative method, or is it considered invasive due to being trash or whatsoever?
Mohammed.
Yes.
Yeah. Well, actually, we have a very well-trained French team with us that have already finished a study on nanorobots and even flying nanorobots that can penetrate through that little hole inside of that chamber, flying around and then going back, sending the data. Well, we still figure out what is the best way. Actually, what I can talk a little bit more than a year before is that in the meantime, we did very many endoscopic measurements. What is obvious to do, because we know how to do that, and the nanorobots, they have the drawback that we have to be 100% sure to get it back. Otherwise, there's an artifact that we lose inside. We don't want to drop some waste inside of that chamber. And with all the hundreds of endoscopic measurements, at the moment, it's processed in geodetical means. So that means that we have a full 3D representation of the inside of the chamber. You saw the videos, that's nice, but for scientific purposes, we really need the measures inside of the chamber. And that can be done by 3D measurements and combining all the measurements and figures to a 3D model. This is what we are working at the moment. Yeah. And also we are working on a concept for the next measuring campaign. That is costly and we are still looking for money.
Yeah.
And this is very helpful. I cannot say that often enough. This is going straight tomorrow to Cairo, and then the Egyptian colleagues can do some preliminary measurements, and that's really very helpful, because this is not looking similar to the ultrasound devices in medical applications, but it's very appropriate for that delicate surfaces. We are not able, or we are not allowed to damage something. You see, this is a spring type, and this can form even on that rough surfaces and have a good contact without any coupling. We cannot put some grease or coupling agent on top of the surfaces. So this is what we are working at the moment, but it's all that slow because we're always looking for money. Did I tell you? More questions?
Yes. Do you plan, or are you aware of plans from maybe other teams? I don't know how organized the field is already, to also investigate other pyramids, maybe also not only Egyptian pyramids, but I think of Mexico or Central America in general.
Yeah, there's a huge survey that we did first. Yeah, as a good scientist, you start with a literature review, what was done, what is undergoing, who's an expert in that field, who can contribute. This is what we do, of course. I should mention that we are not only investigating Khufu's pyramid in Giza, but all the other pyramids as well, the two ones and the Giza Plateau, for example. So just need a little bit of patience, we will talk about that. But also these pyramids are under investigation, not only by the ScanPyramids team, but also by other teams as well. We are very open to share data and to be cooperative. And we exchange once in a while also some experiences, but there's of course also a challenge between us.
First, thanks you very much for the very interesting talk. I noticed during the video that there was a very smooth bore hole the endoscope went through. Did you have to drill part of the way, or was that already there? And if so, why such a small hole? And secondly, were there some traces of gas which are different in this very old room relative to what is on the outside, or was there just always perfect air exchange?
Okay, we did not perforate or drill anything. We have found between the blocks and the mortar, between blocks, a pathway that we could insert a very small 6mm tube, and we were lucky.
Yeah,
absolutely.
Been very lucky.
Yes.
Actually, there's a fun fact into that, I have to say. He mentioned that there have been 6 or 7 huge chevron stones in front that somebody took away in the Middle Ages or earlier. It's not known, it's not in the literature found who did that, but they stopped. Obviously, they stopped in the final row. If they would have removed that, they would have seen that entrance.
Yeah.
And that's really funny. And also that small void between that individual blocks was just large enough for the 6mm endoscope to be penetrated through the hole. So we've been simply lucky, and somebody else could have done that as well. And this place here where we did that is just, I say, 7 or 8 meters above the Al Mamun entrance, where all the tourists are going into the pyramids. So 10,000 of tourists have been passed only 6 meters away from that hidden chamber. Who was here in the room already at Giza? So, and the rest is please going as a tourist soon, right?
Yeah. Your second question is regarding gases inside this corridor. We have not measured it. But you know, this is a closed space for 4,500 years ago, and the environment inside should be different. We did not measure it. It is not our specialization. But if we will have an opportunity to open this place, I don't know how and when and with what organization can do it. We for sure we can take some samples from the gas and the air to measure it.
All right, last question from the room.
Hello, thank you very much for the presentation. And I know it may be not a fair question in hindsight, but I mean, you knew there was a chamber there already in 2015, and you spent like 7 years doing all this imperative science measuring, but in the end you just put an endoscope in the crack. Could you have saved all this time and just put an endoscope in all the cracks until you find something?
Yeah, but then I have a question to you, Beck. Where do you know where to put the endoscope? Okay, you see. So, doing all the data processing, we've been able, not even with the Mayon tomography, that was shifted a little bit upwards to see that we are so close to the outer surface. And knowing the ultrasound and radar measures, then we saw, oh, it's not that far away. Just let's have a look at that particular place. So, but you're totally right, on the other hand. So if there would be no void, probably we were not standing here today and saying, yeah, there is something, an anomaly, but that finding is based on space particle techniques, what is always difficult for archaeologists to see.
Okay, just 30 minutes to highlight here. I have mentioned that we have a discovery in 2017, the Big Void here. We cannot use endoscope, unfortunately, but we are very confident that there is a very large void there. And now we are trying to validate our discovery with additional non-destructive techniques to detect this void. So we were lucky to find a way for the endoscope in this specific discovery, but in other locations we cannot, and we just depend on the science.
So we have one final question, which is from the Zoom stream again. The question is introduced with, ancient Egyptians had several scripts, hieroglyphic for religious and ceremonial purposes, and hieratic scripts for daily purposes. Were you able to find any such scripts on the stones inside the void?
No, we using or seeing these images and videos we have, we could not find any drawing or writings inside the North Face Corridor. And even inside whole the Great Pyramid, there is no writing or hieroglyphic writings.
And well, I honestly believe that this finding will contribute more to the construction history of the pyramid. How is it constructed? Why is it constructed in that way? How big are the stones and so on? So I believe with that new finding, we bring some light into that. But we are very careful, and we are checking. We have to discuss it with other colleagues, and then we will publish.
All right, I think there's a lot of questions left, but I don't want to steal all of your coffee break. There is a coffee break now. Next talk starts at 11:30. And I guess if you have more questions, you have a chance to find those two great speakers today. Give a big thanks to them.
Thank you.